is. Okay, let's get started.
4 in the morning, then.
I see no way that could cause a problem.
So yes, welcome attendees to day 3 of NDC Sydney. Please, would you give a big virtual hand and a warm welcome to the NDC virtual stage? Deploying Docker for Database DevOps Dominance, it's Dan.
Good morning, all. Well, at least it's morning in Sydney. It's, I believe, near the middle of the night for Dylan, and it's late afternoon for myself. So we've got some sun going down while it's coming up for you guys. So as Dylan mentioned, this is deploying Docker for Database DevOps Dominance, and I am Dan Mallott. And we'll make PowerPoint work here. There we go. So quick intro about myself. I'm a principal for West Monroe Partners based out of Chicago in the United States. I've been bouncing around the industry since 2011. I have fairly deep experience with a number of databases, some more unfortunate than others. Early in my career, I was a DBA, and then as one of my colleagues said, I got better, and now I'm a software engineer developer. You see my Twitter, GitHub, LinkedIn. Feel free to reach out to me. Twitter is usually the best way. So why are we here? What do we need to pull this off? So that would be the Docker portion of our talk today. What are we talking about? Unit testing, and we'll do an example workflow and some time for questions. I generally like to have my talks be fairly informal, so if you have a question, feel free to drop it in the chat or unmute yourself and shout it out. I'll do my best to answer or not answer if the answer is coming later. So it should come as no surprise to anyone that databases are special. And there are a lot of reasons for this. Among them, your database holds your data. So Dylan was mentioning earlier that he's got a production database that he does the random number generation against. And this is rather scary, right? And so, ordinarily, when we think about deploying changes to our databases, we have a bit of a mess. For one simple fact. Unlike an application where, the deployment went wrong, we'll just grab the artifacts that we had deployed before, we'll throw them back out there, and nobody will be any the wiser. We can't simply redeploy the data within a database, right? As a result, our database deployments often look a lot like write a script, devise a rollback plan, back up and deploy. Don't forget, you're handing that deployment off to your DBA team to do it when they feel like it, and then pray or cry or just hope that it goes well. And so this is a challenge, right? As particularly when we think about our applications and we have these wonderful continuous integration, continuous deployment processes. So wouldn't it be nice to know the databases changes your team spent months on were going to succeed, ideally without losing data or taking down the environment or anything like that? Maybe we could leverage the same continuous integration, continuous deployment processes we already use for our applications to help us. Or how do we solve for needing to have a database to test our deploys against, right? Even if you think about we've got the deployment stuff all down, maybe it's a little janky, we hand it off to the DBAs, there's a rollback plan, we're all good. But then there's always that round of, we need to make sure we test all this stuff together, and that testing usually happens in production. All these questions sort of sum up to why would we want to do something like this anyway, DevOps for a database? So we'll start with some definitions, just make sure we're all on the same page this morning. So DevOps, a set of software development processes that combine software development and information technology operations to shorten the system's development lifecycle while delivering features, fixes, and updates frequently in close alignment with business objectives. Thank you, Wikipedia. Continuous integration. Ideally, you are integrating your code into a shared repository frequently, running an automated build, and ideally automated tests. And then lastly, continuous delivery. So this would be the ability to get changes of all types, including new features, configuration changes, bug fixes, experiments into production or into the hands of users safely and quickly, but also in a sustainable way. This is generally manifested as an automated release process that allows push button release of those continuous integration artifacts. For some environments, you may do it automatically. So for example, you may have continuous deployment to your dev or test environment, but generally pushing automatically to your production environment is a little scary. So what are the advantages of using a continuous integration or continuous deployment process with our data definition language and data markup language, DDL, DML? So your DDL and DML is part of the application code base, just like your application code. So just like whether it's C# or Ruby or Java or Rust or JavaScript, what have you. Those SQL scripts that define your database are part of the application's definition, right? If we practice continuous integration, continuous deployment in conjunction with storing DDL and DML and source control, everyone gets to see the entire picture of the process and they get to participate as it's moving on. So there's no longer any, well, you'll have to connect to the database and use whatever tool that you're using, whether it's SQL Server Management Studio, Azure Data Studio, Toad, DataGrip, whatever, to be able to see the shape of the database, or to be able to, just look at it, right? Next, your database is going to share a common development, build, and deployment mechanism. So it's very nice if when you open Visual Studio, you have your database scripts there right with you, right alongside your application code. If you're using Visual Studio, whatever you're using, right, if it's close at hand. You can definitively answer what was deployed for the entire application rather than just for your database. Or sorry, rather than just for your application code itself, right? This is a question that is, I hope that you never have to take on yourself, but I've seen it in my own past where, so what exactly did you deploy? Yeah, we deployed some stuff. What do you mean it's not working? And lastly, building and testing your database can help identify issues such as misspellings, missing objects, or unexpected regressions. So, that could be something like you renamed a table and all of a sudden all of the stored procedures that depend on that table broke, or perhaps you were renaming a column and dropped an L, added an extra E or something. And so all of these lead us to want to use all of those things that we do with applications with our database code as well, or at least they should. So what tools do we need to make this happen? All right. So the talk is called Deploying Docker for Database DevOps Dominance. So we're going to start with Docker. And the simplest way to get started using Docker for your database is to use it for your local development environment. How many out there use a machine where it is difficult to install Microsoft SQL Server? Yeah, I got at least one. Or where you might not want to have a Postgres database hanging around, or and God help you, Oracle or DB2, right? these are all available as Docker containers. Docker is a really nice thing. You run up the container, you do your work, and then you turn it off so that it doesn't kill your battery while you are enjoying the conference or doing whatever else you're doing. Ultimately, we can leverage these as well for integration into our testing and deployment pipeline. And we'll get to that in a little bit. The important thing here, these may not be appropriate for production workloads. I know that both Microsoft and Amazon have done a fair amount of work to get some reliable storage along with their Kubernetes, but production workloads, containerized databases, yeah, it still doesn't feel great. But we can absolutely use them temporarily. Now, I mentioned Kubernetes. So this is the other side, hosting, right? We need some place to put these. So I mentioned that we're going to be leveraging this during our build and deployment pipeline. And I'm building to something here, so just stay with me. But we're going to need somewhere to temporarily host our Docker images, right? Actually run up containers to be able to access where they're going to run, and they're not going to just fall over for no reason, but where we don't really care if, you know, that we can just tear them up and down fairly quickly. So in this case, we don't have to worry too much about orchestration, unless you're going to perform some fairly in-depth integration testing. The main concerns are finding something that's going to have enough storage space and not going to kind of fall over when you restore your 50 gigabyte database to it. So we've got some possibilities. Azure container instances, Azure Kubernetes service, and then Amazon, either ECS or EKS. And then, if we're running a discrete build server, we can use the discrete build server itself. And in this case, that may be the preferred option, which we'll get to why that is a little bit later. And so in a lot of cases, these are going to come down to how much orchestration you need and how much cost you're willing to take on as part of this sort of operational build and deployment process, right? So something like Azure Container Instances is very cheap. Something like EKS might not be, right? It kind of comes down to where you are. I'll pause for any questions. Everyone's still awake, which is good. At least everyone I can see is still awake. All right. Now, how many of you have your database code in source control today? 1, 2. I'll assume that everyone who doesn't have their camera on is returning, which is good, right? We should. This is something that we should do. But as just a collection of scripts, that's kind of it can be kind of frustrating. So we want to think about using a better tool for this. So something that's either state-based or migration-based. So state-based tools essentially generate a diff script to upgrade the database by comparing what you have in an actual existing database against what you have in your model and generating a script to make all of the changes, which that can then be either automated or run manually. So some examples, SQL Server Data Tools, Radiate SQL Source Control, both pretty good at this, but there are some challenges there, specifically around making data changes, data type changes, naming things. Naming things is one of the two great challenges of computer science, along with cache invalidation and off by one errors. So the other side of this is we have what are called migration-based tools. And so this is essentially unlike a state-based tool where you can generate a diff script against any version of your database and migrate all the changes, a migration-based tool goes at discrete points of migration. So we have, I'll create a table, create another table, I'll create a foreign key, and each of those would be a different migration, or could be a different migration. And so you have what's called a baseline version, and then you make changes. And those changes, when you deploy them, have to be applied in order. So this makes doing things like updates to data or data types or naming a little bit smoother. So some examples, we have Flyway, Liquibase. Those are the two large sort of cross-platform ones. Along with things like Ruby on Rails migrations, Entity Framework Core, if you do the database migrations that come with that. Other ORM migration tools tend to work the same way. So version control, databases, you should do it. And so I'm going to switch over and just kind of show, at least in Visual Studio, what this looks like for SQL Server data tools. I'm going to combine a couple of concepts that were one that I'll cover momentarily. So in Visual Studio, we have, and Dylan, let me know if this is large enough for people to see. So in Visual Studio, we can have what are called database projects. So in this case, I've got two, one that is just the database and one that's the tests. And I'll get to the idea of testing a database in a moment. But we simply have tables that have definitions, both in T-SQL and there's a designer, of course, as well. And this is all nicely organized and in Visual Studio. And I can do things like click build. And it actually does a build and produces an artifact that I can use to deploy against another database. Or it can fail, which is fun. This is why demo is a 4-letter word, and you don't mess with your demos right before your presentation.
You gotta love the maximum number of 200 errors has been reached.
Yes.
Yeah, that was always one of my favorites as well.
So in any case, it looks like I'm missing something from this installation of Visual Studio, which is not unexpected. So in any case, you can kind of get the point. We've got all of our scripts. They're in a solution in Visual Studio. These are, in fact, checked into a GitHub that you can go and pass judgment on if you wish. And then there's the other concept that we have here, which is tests. So let me switch back, and we will, let me switch back to the actual presentation. Yeah, so unit testing. So this is something we do in our application code, but did you know you can do it with your database code? So first, a quick question. Do you have business logic in your database? So if you don't think that, if you don't think that you do, then the question that I would ask you is, do you have foreign keys or default constraints or unique indexes or anything like that? Because if you have any of those, then you have business logic in your database, even if you aren't necessarily thinking about it that way, right? And so all of that business logic ought to be tested just the same as we ought to test all of our applications business logic. So now you might write a huge API that has no unit tests in it, but you shouldn't. And we all sort of generally accept that. But unit testing in your database is kind of important as well. Particularly because things like SQL Server or DB2 or Postgres are not always particularly picky about telling you when a change that you have made will totally mess you up. Oh, look, you changed the name of that table that's referred to in 40 stored procedures. Well, guess you'll find out the next time you run one of those 40 stored procedures. Unit testing helps with this. So does building your database, right? But don't necessarily have to do them both. So there are a few database unit testing frameworks that are available. I quite like T-SQL-T. It's a open source one for SQL Server. There's also Redgate SQL Test, dbfit, ndb-unit, db-test-driven, which does just SQL Server and Oracle, of all things. And of course, as with everything, unit tests can only be effective when you run them, preferably in an automated fashion. And I'm going to pop back out to Visual Studio so that we can take a look at what one of these tests actually looks like in a very sort of basic fashion. I'm happy to answer some more questions about T-SQL-T if anyone has them after we get done here. So all of the tests are defined as stored procedures, and they all kind of look like this. Now, obviously, this is very simplistic. It's just counting the number of records that are found in a lookup table, but kind of looks the same, right? We have an arrange, act, and assert pattern. So arrange, act, and then the act and assert are kind of in the same place here. And so this things like this can point out when you have problems. And so it's worth looking into maybe starting to use some. Any questions about that? Go back to the. All right. So the last component that we need here, of course, is the build server. So you're going to need a build server that can run your pipeline in an automated fashion. I'm guessing you have one of those already. So the one that builds your application server ought to be able to build your databases as well. Fairly popular ones. The most important factor here, though, is it should support whatever tools we have chosen already. So that's, you don't want to have to do a lot of extra finagling to get all of this to work. So SQL Server and .NET, Azure DevOps is a great choice. As I mentioned earlier, something that runs on your own build server might be better. And so we will look at that as well. So what does this all look like? How do we put this all together in a way that leverages all of the things that we're doing to build a database, run tests, maybe run some integration tests, and then not leave a giant footprint behind? So this is a very basic DevOps pipeline, right? Restore the code, build the database project, or generate the migrations, depending on your tool. Create a Docker container with the database, potentially restore a backup. So that is, if you are, depending on where you are in your product maturity, right? Deploy built database code, run unit tests, and then clean up, right? So at least for me, I tend to do lots of these things in the cloud. I don't want things sitting around where Microsoft can continue to bill me money. As much as I like giving money to Microsoft, I don't like giving it unnecessarily. There's some additional work that we can do here. So if we think about it holistically between an application and the database, we can build the application in the database. We run our unit tests in the application. We have to deploy the database container first, run the unit tests in the database, deploy applications to containers, and then use that to run all of your integration tests. And that's obviously a potentially much wider topic, but then we can have a success or failure, and we already know that whatever we've done is going to work out very well. So now what does this look in practice? So we're going to look at this actually in Azure DevOps here momentarily. And then as we're actually executing the demo, we'll talk further about some improvements that can be made. So. All right, can everyone see the lovely Azure DevOps? Cool. So there, we're going to come out of 2020 with some catchphrases. Can you see my screen? I think you're on mute. No, really, you're on mute. Why is there a cat climbing on your head? That's usually what people ask me. Right, so we can see our pipeline here. So in this case, we're building a main database, doing our database tests, and then I'm using Azure container instances to simply deploy a Docker container very quickly. So creating a container resource group, creating the test container. So that's just in this case, 2017 SQL Server. Again, in the don't update your demos right before you demo them category. Couple of things here, and I can make the YAML for this available if you promise not to hack my database that doesn't hang on for very long. We then deploy our main database objects to the container, the test database objects to the container. We run the tests, which for tsqlt simply involves running a single command. Get our test results out, publish the test results, and then if this succeeds, we can publish the main database. If it fails, we don't. And at the end, we clean it up. So we'll go ahead and kick one of these off. We can see this running. We'll see if I get see if it gets a build agent right away. In the meantime, any questions from anyone?
So one question in the chat, someone's saying, when would you consider using integration tests versus database tests? And someone else saying, yep, which I assume means they had the same question.
Yeah, so when would I consider using integration tests versus database tests? So I would ideally, and of course we don't live in an ideal world, but ideally I would use both. So just the same as you wouldn't use either unit tests or integration tests for your application code, I would prefer to use both unit tests and integration tests. However, we don't live in an ideal world. And I think where I would draw the line is if you already have unit testing going in your database, then it's easy to add on to that. If you're starting from scratch and you already have a rather large database, that is a project with a capital P. And so in that case, it's probably going to be easier to get this working with integration tests. Simply for no other reason than you already have a database that you can restore into a container and run, and you probably already have, whether it's Postman or SoapUI or something else that can test your application, or some Selenium tests or what have you. And so it's really, to me, a question of time and money at that point.
Would you say
kind of answer the question there, Anthony?
Would you say that there's just sort of following on from that question came to me. So something that I've often seen is code where certain database operations are mocked for the sake of making the tests easy to run. Have you ever seen kind of you mock the database when you're testing the code, but then use database testing separately to verify that element of the behavior, and then you assume that when you plug them into one another in production, they're going to work properly? Is that something you've worked with?
Yeah, well, so mocking databases is something I'm very familiar with.
Yeah.
Anyone who's anytime I've worked with Oracle, that's very easy to mock. But I suspect that's not entirely what you're going after. Yeah, so mocking your database in your local development environment, and then sort of testing your database separately, and hoping that all works together in production is. I have seen it done. I have seen it work. It's not something that I would necessarily bet my career on if I were to say that. I think you know, if you have a choice there, you should ideally be giving your developers something that looks like the real database to develop against anyway. But then you want to be able to test that before it gets to production. Yeah, tips on seeding complex large databases other than building massive seed scripts manually and carefully. And so as I'll get to that question in a second there. So one thing that you guys have noticed over here probably is that there are some kind of slow things about this continuous integration pipeline, which are pretty much straight to Azure container instances, and they're not the quickest to start from scratch. So in this case, at some point I'll do a dedicated build server, which will speed this process up significantly because I won't have to do all of this. I'll just already have Docker running. So tips on seeding complex large databases. So is this, so James, are you thinking about like lookup tables or the actual data that they have, like the actual data from the database? Like the actual like transactional data, I guess I should say. Both. Okay. Yeah, so for lookup, so for lookup tables, it should generally be possible to create that script. If you have an existing database that you're creating this off of, you can sort of reverse engineer the data. So SQL Server has some tools for this. I know there are third-party tools that do that fairly well as well. You know, you can also script that out so that you pull it out. But for the actual data that you have, the actual transactional data, my general preference would be to restore from a backup. Now, there are considerations there, such as you don't have, you know, if you have the need to scrub your data, clean it, de-identify it, you know, that may be a challenge. Yeah, I would certainly draw the line. The lookup data I would consider storing in source control. Assuming it's not created by users at runtime, you know, in like a WordPress type situation or something like that. But your actual transactional data, I would expect should come from a backup, in my opinion. All right, when unit testing code, there may be dependencies, which mean you cannot unit test. Are there such scenarios which, yeah. So good question there. Dependencies, which mean you cannot unit test. So in the SQL Server land, and I'm most familiar with that, so I'll kind of answer from that perspective. I would think the one of the big ones would be any sort of cross-database querying tends not to turn out so well, or cross-server querying. I would strongly argue that things you cannot unit test in an application, things you cannot unit test in a SQL database. If you are having the conversation that you say, I cannot unit test this, then there's some rethinking of the architecture that probably needs to be done. Because we ought to be able to create seams such that things are able to be unit tested. And at least in the SQL world, the database world, the unit test frameworks all provide the ability to mock certain pieces of the underlying database platform, such that you don't have to like worry about permanently changing data in your backup. So it creates those same sorts of repeatable run unit tests that you should have in your application. Does that kind of answer the question, Anthony? Up for the purpose of running automated tests. Do I have suggestions for when that would be an issue? So ideally, again, we don't live in the ideal world, but ideally you would have a representative sample of your database that was not terrifically large. So I mentioned over on the screen that I'm sharing, like 6 minutes 30 seconds for this is kind of a bit long. So now imagine you add a 50 gigabyte database restore on top of that, right? Even if I take Adam's suggestion there and use the Docker that's available on the build agent, which, full disclosure, it wasn't when I did this originally. Even then you're talking about adding 50 gigabytes of data somewhere, and that's not necessarily quick. It also could be costly. So ideally you have a database that is small enough that it restores quickly, but diverse enough that it has all of the data you need. I think that if all you have are multi-terabyte databases, then probably using real data in your tests is probably going to be a non-starter. But that you would want to look at doing a decent selection of mock data. And again, that's something you can either roll yourself, or there are some tools that can help you with that. Redgate makes some excellent ones. Redgate does not pay me. They just happen to make excellent tools. So Brendan, does that answer your question there? As much as it can be answered? Yeah. Great. So notice this succeeded over here. It took a decent amount of time. We could cut this down. But when we finish it, we do get a nice report of all 2 of our unit tests passed, which is great, because now I can deploy this with some certainty that the 2 things I'm testing are not going to blow up and cause any problems. All right. Back to PowerPoint. Right. So we saw the example pipeline in action. So I do have some additional thoughts on this, and then we'll have some additional time for questions. So there are some things that this doesn't work very well for. Data type changes. particularly, so changing something from a 32-bit integer to a 64-bit integer, most databases are going to handle that fairly smoothly. But if you're going the other direction, or if you're changing from, say, an integer type to a character type, now you have a much bigger challenge. If you're using something like Flyway or Liquibase, where you have a migration script and you can write all of the logic to fix that during your migration, it's going to come out fairly smoothly. If you're using something state-based, then you sign yourself up for a fairly large challenge, and it's not great. Any sort of large-scale refactoring. So, for example, if I'm going to change the names of all of the tables in my database to something randomized and put views in their place, don't know if I want to try to shove that through a continuous integration pipeline. I might be better off simply writing some scripts to do it and doing that out of band in a service outage. And then lastly, and kind of in reference to the question about multi-terabyte databases, this isn't, we aren't really going to want to use this for load testing. So in addition to some of the size and time constraints, right? One of the things inherent in continuous integration, continuous deployment is that your database, that all of your builds should happen quickly. Otherwise, they're not as useful. So, quick story from a project my company worked on. The development build took 40 minutes to run, which is awful. So can any of you guess how many times they actually merge to develop every day? It was greater than 0. Yeah, it was more like once or twice, right? And so we don't want the time we spend in our builds to be a blocker to actually doing our builds, right? Because now all of the advantages that we get from everything that we've talked about, we now no longer have. And that load testing falls in that category. The other thing to think about with load testing is if you load test your database in isolation of all of the other things that happen to be running on the server around it, you're not necessarily going to get a true picture of where the application is having performance challenges. Also, if we're load testing against anything other than a production data set with a production level workload, you, again, are not going to get a really good picture of where you have problems. So I'll say this once again. Load testing in a continuous integration process like this is a bad idea. Not that you cannot leverage the automation tools to do it, but I would strongly urge you not to. So for all of you in the audience, can you think of anything else, any other cases where this might be problematic, or where you might run into some edge cases, corner cases? Oops, I just chopped off my foot cases.
One of the weirdest ones I've ever seen is coercion between ANSI strings and Unicode strings, because that only shows up when you're running things over a connection. When you copy and paste your code into the query analyzer and run it, it's fine, because it parses it using the correct character type. I've had some real fascinating stuff with stuff that worked when you tested it and then didn't work when you did it for real. So I don't know if that answers your question, but that was a lot of fun.
Yeah, that one's go back to the data type changes. Data types are a weird thing. Yeah, especially for for us Americans because we tend to ignore the fact that there could be anything other than Roman characters out there, which
You're
is
not the only ones.
well. In any case, what if the live data is changing quickly and the thing you want to deploy has data across tables with some foreign key constraints? Yeah, so that would be another one where I would say that you can probably use this sort of continuous integration, continuous deployment. In fact, you could probably even get a pretty decent unit test or integration test around that. The challenge there is going to be how your database platform handles actually implementing the foreign key constraint in the database. So what I mean by that is it might work fine in your tests, even when you're putting data in and changing data and having all of that. But you may run into an issue where in the production database, you're deploying these tables and foreign key constraints, and you accidentally take down access for all of your users. And so for that, I would suggest a good outage window. So it's just something that you would want to think about so that you don't run into the customer service people ringing you up and grumping at you. Or losing users, right? You know, depending on how bad the outage is. What else? Anything else? Would I do blue-green deploys for DBs? Let me go back to so databases are special. And so, unfortunately, they don't lend themselves really well to a blue-green deploy. It's not to say that I wouldn't. So when I think about that, the challenge really is that you're going to have to choose a time when you cut off access to your blue environment so that you can get the same set of data into your green environment. It's like having a tough time wrapping my head around how that would actually work in practice.
We did actually try and do it once years ago. It's very, very hard. Yeah, basically the problem in a nutshell is customer creates a record, it goes into the blue database, then you flip over to the green one. You can replicate code trivially. We ended up using a primary replica configuration, and at any point it wasn't true blue-green because it wasn't kind of switching everything, but it was like, right, we'll switch everything from the primary to the replica, upgrade the replica to primary, and then the old primary can sort of slowly fall away. And we tended to use that for doing system maintenance, which didn't affect the state of the data, as for doing things like operating system patches and those kinds of things. So you'd have the same data replicated between a box that didn't have the latest Microsoft update and the one that did. And if everything was good after 24 hours, the replica became the primary and the old primary. But doing blue-green on data. And here it is, the question I was looking forward to. So you need to roll back a release. How do you deal with reverting database changes that could lose data created in a recent change?
Yeah. Well, so this is the real challenge, right? Is say you've created, you've done your migration, you have new data that is, whether you updated some data or you changed it, you changed the structure, you took a backup before you deployed, so you have a known good state, but you don't. But you've had the new one be on for a while, and users have been using it. And so really there's not a great automated way to handle this, unfortunately. It essentially boils down to, are you willing to lose a bit of customer data and go back to your known good backup? And so, if you've only been online for like 5 minutes, maybe that's okay. Or are you going to, do something where you restore your known good to a separate server or the same server and migrate the data as best you can? But unfortunately, no, not a great automated way to do that. I wish I had a better answer for that.
Again, this is something that my team, back when I was at Spotlight, we dabbled with. A lot of the stuff you've been talking about is stuff that we were also sort of trying to figure out. And one of the things that helped there was if at all possible, we would avoid doing the data schema change and the code change that populated it at the same time. So classic example, you roll out a release which adds a new column, and then you need to roll back. Now the column's not there anymore. What happens to all the data that the customers put in the column while it was live? So what we'd do is we'd roll the column out first, but the code that talked to it wouldn't be accessible to production customers. Only test scripts that had, the magical cookie or connected directly to the APIs would do it. And we'd give it, 48 hours to make sure everything was good. And then we'd roll out the code, because at that point, if we had to roll back the code deployment, we knew the data would still be there. It's just you couldn't talk to it anymore. But it is, there are, I think, certainly questions around state management and, rollbacks and stuff that when the second you switch a feature on, a customer gives you information and goes, remember this is yours now. At that point, rolling back is just really not an option, because it's like, well, no, we can't, that's got to stay. So, but no, it's a really interesting discussion.
Yeah. So this is where, so I as I've mentioned and as I showed, I've preferred SQL Server data tools in the past. It's one of those where I'm more and more defaulting to something like Flyway or Liquibase or something where it is, yes, exactly, you fall forward. Where this didn't work, we'll make a change that reverts it by moving the state of the database forward. So we'll go back over here. And this is my last slide, which is questions. I have about 5 minutes left. So any other questions that we have? So
one question, which is, I guess, slightly unrelated to the topic, but I'm curious of your opinion about NoSQL databases. Obviously, you're somebody who spent a lot of time working with relational databases. Have you done much work with things like Mongo and Couch and RavenDB?
So Mongo, yes. Cassandra, yes. Cosmos, yes. I like relational databases because for 90% of your problem space, they're going to solve your problem really well. But there are cases where it makes sense to use NoSQL, where you're storing a document, or you can allow your application, your API, to worry about all of the business logic around what that object should look like, and you don't need a database to do that for you. And I think that's where things like Mongo or Couch or Flavor of the Month, Maria's relational, I guess, all of those work really well. We've also, at my firm, been using Postgres a lot more recently, because you get really the best of both worlds there. You get a nice relational database that has some really fantastic document capabilities.
Cool.
So,
yeah.
Nothing wrong with NoSQL. Nothing at all.
I'm kind of the same camp as you. I like the relational model because I find the constraints reassuring, but was very impressed with Postgres and how that handled kind of documents as part of a relational model.
It's like, yeah, everything makes sense up to this point. So after that point, it's just JSON in a JSON column, and that'll be fine. So yeah.
And it's interesting when you look at SQL Server and how Microsoft has tried to solve the same problem, and I don't think done really well.
Yeah, because they used XML for it. But so I just noticed Emily said in the chat, for all those reasons we built Nevermore. I've not heard of Nevermore, Emily. You want to tell us what it is?
I probably can't do it just. It's based in SQL, but it's a JSON blob store. So yeah.
Cool. We'll check it out
as well. So accepting pull requests.
Oh, awesome. Good
All
stuff.
right.
Cool. Right, we got about another 2 minutes. Are there any other questions or comments? We've had some pretty good discussions so far over the course of this.
Yeah, Martin, for that one, I would suggest if you really need to index into your documents, then yeah, a true NoSQL or even something like Elasticsearch is probably going to be a better winner than using Postgres or SQL Server.
Or you give Mongo to your junior developers and they will build a relational database on top of it and think they're really clever for having done it. This is also a solution.
No comment.
Cool. All right. Thank you very much, Dan. Awesome.